This is the foundation of trigonometry, so it's a really important day. You've got this on video so that you can rewind or watch over as the weeks go by if you forget how to do something. What we're going to do is we're going to start today something called a memo page. While I'm not big on memorization, this is going to be really important. There'll be some things you have to memorize. I'll explain everything as I go. You know, just like somebody explained to you addition and multiplication. But eventually you have to memorize those things. And there's a lot of things about trigonometry that people need calculators for and technology, but there's lots of things that they know just off the top of their head. So just like you should know 8 times 7 is 56, the time's coming where you should know that the sine of 150 is 1/2. And I'll always alert you when you're going to write on your memo page. There's other pages you'll have just for notes, just taking your notes, da-da-da-da-da. And then I'll say, oh, now it's time to write something on your memo page. When I say that, I'll box it in and I'll pause and give you a chance in class or in a video to write it on your memo page so that you know what a memo page looks like. By the way, I have people that definitely take these to college and beyond because, like I said, it's trigonometry all in one page, and it's in your own handwriting. It's something you develop and understand as you go. It's not just something you look up. It becomes your own property. So if you're on topics, here's somebody's from last year. I think it's Katie Lapolis, but this is eventually what it will look like. Okay, it'll have all your trigonometry on one page. Sometimes people lose theirs, and so I have this here, but don't even look at it now. Really, you'll learn it as you go. And also, if you pay attention in class and do your homework, you don't really have to worry about memorizing it. It will happen naturally just as you're looking at it to do your homework. Keep this memo page in the in a prime location, either in the very front of your notebook. Have a little slot for it in your expandable binder, in your expandable folder, in the very back of your notebook, wherever it is that you keep it, because every time you want to do homework for the next few months, you will want this as a handy reference page to look at. That way you're also not having to look up stuff on videos or out of the book. It'll all be right here on this page for you to look at. All right, so let's get started with trigonometry, which is very exciting. Okay, I love trigonometry. So now I'm just talking. You should have maybe paused if you needed to right now and had a memo page ready. And then, so do that now if you haven't done that already. All right, so here we go. I think everybody knows that sine, let's call this X for now. Many times we'll use Greek letters in trig, like theta and beta and alpha. But a lot of times we'll use just A's and B's and X's. So I'm going to go ahead and start using theta. That just is a variable, though. I could just call it sine of X or tangent of X or whatever. All right, there are 6 trig words that tell us to do something to an angle. Now, what's interesting is all of a sudden you have a word. Well, not all of a sudden. You saw these in geometry. You saw a word introduced into your math world instead of just like a times or an addition or a division symbol. Now all of a sudden there's a word that's telling you to react. But just like this is saying take 3 times 4, or what if you have 3 apples plus 4 apples or whatever, the word sine is really a math command. Cosine, tangent. And then the other 3 trig words are cosecant, secant, and cotangent. There are abbreviations: sine, cosine, tangent. Cosecant, the COS is already taken, so CSC is cosecant. Secant is SEC, and cotangent is COT. Now, up until now, most of you maybe only knew these 3 trig words, and there's not more than 6. This is it. But if these are the only three that you knew, you may not have noticed up until, you may not know what we're going to notice now, that there's a sine and a cosine, a tangent and a cotangent, a secant and a cosecant, and those do have something to do with each other. They are what we call cofunctions. We'll get to that another day. Now, sine means to take opposite over hypotenuse. Cosine means to take adjacent over hypotenuse. Tangent means to take opposite over adjacent. And these, I'll teach you what those mean in just a minute, all of these three. I think most of you know SOHCAHTOA. If you don't, you need to know that. SOHCAHTOA, we'll write that on your memo page. Let's go in and do that right now. Well, in just a minute. Just like this or this, division bar or multiplication makes no sense without numbers with it. These are math symbols that make you do something. Divide, divide, divide. So I'm sorry that they're words, I really am, because it makes people confused to all of a sudden have words in their math, but all they are, I wish somebody had made up symbols instead, but they didn't. So, but they're super easy. It's just as easy today as me teaching you to say 3 times 4 is 12, or 3 plus 4 is 7. Sine is a command to take the opposite of a triangle and divide it by the hypotenuse. Cosine is a demand, a mathematical operation. So anyway, if sine is a mathematical operation that's opposite over hypotenuse, which is very easy, it can't stand alone. It doesn't make any sense for you ever just to write the word sine all by itself. So don't ever do that. You need the sine of something. Right now we'll work in degrees. Later on we'll work in something called radians. We might start that on Wednesday. All right, so always put a letter back here, like X or A or whatever the problem or the book is using that you're working on. Right now I'm going to use theta, because I'm going to be using the letter X for something else today, so I don't want to confuse you. Theta is just another variable that we use in math. I quite often use an X or an A, but like I said, right now I'm just going to kind of get you used to using this math symbol, this Greek symbol theta. And we use it a lot for an angle. You may have seen it in geometry. All right, so we're going to have sine theta, cosine theta, tangent theta. I'm going to teach you today what cosecant, secant, and cotangent are. Let me go in and show you, and then we'll write it on your memo page. The reason that I'm writing them in this order actually is these are reciprocals of each other. These are reciprocals of each other. And these are reciprocals of each other. So sine and cosecant are reciprocals. If sine is 5 over 7, then cosecant is 7 over 5. These are reciprocals of each other, and these are reciprocals of each other. Again, very easy. You just have to learn the ropes. All right, so let's write some things down on our memo page in just a second. So it's based on right triangle trigonometry, whereas this is an angle. We talked about angles the other day, like a reference angle. And we have a right triangle, and this is opposite, adjacent, and hypotenuse. Now there's another angle up here, but we're always concerned about the one that is to the closest x-axis as we're going around our circle. So a lot of times I don't draw the circle, but remember this is part of going around. That's how we get our angle. Now, remember we talked about our butterfly, okay? Always remember this purple. You don't want to go this way. You're not talking about what's going on with 90. Not. Let me hit undo. Okay, so we're looking at the purple for our reference angle as we wrap around our circle. When we land somewhere at an angle, let me get this undone too. When we land somewhere, we get this angle right here. We get this angle right here. And from that angle, we get the opposite over the hypotenuse, or the adjacent over the hypotenuse, or opposite over adjacent. All right, now, so let's write that down and then we'll put it on your memo page in a minute. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So you have SOHCAHTOA. All right, so I'm going to box that in. Give you a minute to write that on your memo page. I'll be doing that right here. So we have sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. SOHCAHTOA. I'm pausing while you write it on your memo page. Don't ever take notes on your memo page. You just write facts that I box in. All right, I'm moving on. If you're not finished writing, you can pause me. Okay, now the next thing we're going to write on our memo page is I need a way to tell you that they're reciprocals of each other. Like if sine is 10/11ths, cosecant, remember that's C-O, cosecant. Cosecant is 11/10. And so the way for me to tell you those are reciprocals of each other is that cosecant is 1/sine. Don't ever write on your memo page until I box it in, because right now I'm just developing the concept. When you see secant, all you do is say 1/cosine. And when you see cotangent, you say 1/tangent. Now, why am I writing it this way? Also, the reverse of that is true. When you see sine, it's 1/cosecant. Cosine, you can replace with 1/secant. And cotangent, you can replace, if you ever need to, with 1/tangent. Oh, I just wrote that, sorry. So I'm looking at this one, and that just means they're reciprocals. So tangent is also the reciprocal of cotangent. So the reciprocals of each other. If cosecant is 1/sine, sine is 1/cosecant. If secant is 1/cosine, cosine is 1/secant. If cotangent is 1/tangent, then tangent is 1/cotangent. Now, how does that make sense? Why am I writing it like that? Why am I writing sine as 1/cosecant? Okay, because it's a great way to mathematically tell you things are inverses. Like, for instance, let's look at 10/11ths. What is 1/10/11ths? Most of y'all say keep, change, flip. I always used to say instead of dividing by a fraction, you multiply by the reciprocal. This is 1 divided by 10/11ths. So we keep, change, flip, and that gives me 11/10. So a way to say here's a number and here's its reciprocal. So if I have some number x, its reciprocal is always 1/x. In other words, if x is 2, its reciprocal would be 1/x, 1/2. Do y'all see how that's working? Okay. Let's take a/b. What if I take 1/x, 1/a/b? That would be keep, change, flip, and become the reciprocal. So do you see, if I have a number and I put 1 over that number, this is the best way for me to tell you the reciprocals of each other, except for writing it out in a sentence. So from now on, when you see these things, it's a notation that they're reciprocals of each other. And it can be written either way. They're reciprocals of each other. So that's always a way to say that two things are reciprocals of each other. You can just say 1 over that item, and it will make it flip over. All right, so on our memo page, I'm going to write the reciprocal identities. And we're going to be learning these things called identities. We mean they're always true. There's some things in math that aren't always true. And on our memo page, our identities will be things that are always true. They're identical to each other. So you'll have lots of identities on your memo page. Don't write yet. Let me write first. All right, so sine cosecant theta is 1 over sine theta. Secant, don't write yet. Secant theta is 1 over cosine theta. Tangent theta, sorry, I usually write these over here. Cotangent theta is 1 over tangent theta. Please don't write yet. You'll see why. Now, some people like to write all 6 and then write sine is 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. Some people like to write all 6. I don't think it's necessary, so if it was my memo page, I wouldn't. I would just write these 3 because it says what you need it to say. They're reciprocals of each other. You'll get to where you can look at this and know, oh, cosecant and sine are reciprocals. But if you feel like you want all 6, you've got time right now to write these down too if you want to. I didn't write the other 3 very neatly, so like I said, if it was my memo page, I would just write reciprocal identities and then give myself some room to write these 3 as my reciprocal identities. So you may want to pause and write whatever you need. Okay, while we're here, sorry, I was pausing while you were writing. While we're here, we're also going to write something else next to this, which you may be upset because you're thinking, well, you didn't tell me this was coming. You didn't give me any room to write it over here. That's okay. Yeah, I'll show you what to do if you don't have room to write something right in here. Because I'm going to move you away from geometry and into trigonometry. And also, this SOHCAHTOA doesn't help with everything that we need. We need to be more specific. All right, so let's go to a triangle. Now I'm teaching. You're not writing on your memo page anymore. As you go around your go around your circle and you land and you get an angle. Remember, this is the angle that we're most concerned about right here. Okay. What we'll do, like this is a big old circle going around, okay? What we'll do when we get to an angle is we'll stop at the terminal side and we'll drop a perpendicular down. So really the only point that's actually on the circle would be this one right here, x, y. And so if you look at this, we go back x and up y. This is actually an x-coordinate and a y-coordinate. So let me draw that darker. This is an x-coordinate, like you're really going back on the x-axis, and this is a y-coordinate. So this might be a number like, this might be like -2, 3. Now as we rotate around our circle, we'll always land on the circle as we rotate around and find an angle. Don't forget to always look at this angle, not this one. Sorry, I didn't mean to undo the whole thing. Remember, we're going around a circle, but many times we don't stop and draw the whole thing. This is the radius, and to get to this dot, what we would do is we would count x and y, and we're going to make a right triangle right here, okay? And so this is x, and this is y, and this is r, so that we can get everything that we need. Now, one thing I want you to notice, if I was finding sine of either one of these angles, watch what would happen. I'll do it in red so you can see it clearly. If I was taking sine of this angle, I would go opposite over hypotenuse, opposite over hypotenuse, which if you look at the hypotenuse, it's always going to end up being like this clock hand or the radius of this circle. Let's look at this one. If I'm looking at this reference angle, okay, my opposite is y. Opposite over hypotenuse is r. Sine of theta is always going to be the letters y over r. Wherever you land in your bow tie or your butterfly, you're always looking at the closest. These are thetas. Closest x-axis. If you look at the opposite side, opposite this angle is always going to be some sort of a y coordinate where you count it either up or down. Opposite's always going to be y. Adjacent is always going to be an x coordinate. To this angle here, adjacent's always going to be an x coordinate. So you will have counted out x and like up y or down y. And the hypotenuse of this angle is always the radius of the circle. This hypotenuse is always going to be the radius of a circle that quite often we don't finish drawing. It's going around like this. Okay, so sine is y over r. Cosine of an angle is this side, which is your x-coordinate. Cosine of an angle, if you look up here, it's an angle. Cosine would be adjacent over hypotenuse. So it'd be adjacent would be your x-coordinate over hypotenuse would be your radius of your circle. So cosine, we're going to move to x over r. And let's look at what tangent's always going to be. Tangent's always going to be opposite over adjacent. So I'm going to move you out of SOHCAHTOA more and move you more and more toward really using points on the circle, okay? So sine is always y over r. And if you ever forget this, remember I explained it to you. You can slap a triangle really quickly onto your paper, and you can label the sides. If you're thinking, let me draw that bigger. Okay, if you moved around here and you had this angle, and if you drew it a little, I don't know why that's so squiggly. Here's my angle, and sine of my angle would be opposite. I can see that is literally x, y, and r. So I can see that this is my angle. Sine is opposite. That's my y coordinate. That's my y coordinate of this triangle. And cosine of this angle, that's my x coordinate. And this is the radius of the circle. So we can revisit that, but let's write these on your memo page. All right, so what I'm going to do is I'm going to insert them here and go more and more toward this. Instead of SOHCAHTOA, I'm going to say sine is y over r. I didn't leave much room myself, so I'm going to sort of cheat and erase. If you don't have room to squeeze it in, I'll show you what to do. Sine, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. We're learning to label them differently now. Sine is y. This is more trigonometry. Sorry, I'm not sure what's happening with my iPad. Sine is y over r. Cosine is x over r. Tangent is y over x. If you don't have room, maybe you can squeeze it in somewhere else. You could just write yourself. That looks like it's part of the reciprocal identities, though. So maybe underneath it, you could write yourself a note. That's not big enough, but you could just rewrite it, I guess is what I'm saying. I usually remember to tell people to leave some room. But if you need to, you can just write underneath here, sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x. I'll pause while you do that. Okay, so make a choice. Like, I'm going to keep going back to my memo page during the lesson, the rest of the lesson. And so I got mine squeezed in. All right, now if you're not ready, just pause. And this is what should be on your memo page now. In the future, I'll try to write reciprocal. It would have been better had I written the word identities underneath the word reciprocal or something so that it fit better, or you may have just stretched yours out to fit underneath there. Okay, so now how are we going to do this? I want you just to watch, like don't write anything down. Just watch and remember kind of what you did with your quiz the other day, okay? I'm also going to move you away from geometry and all the little, we're eventually not going to have time to do the normal triangles where we have 30, 60, and 90. You're going to be memorizing sine, cosine, and tangent for those angles. And the good news, if you know sine, cosine, and tangent for those angles, you're also going to automatically know their reciprocals. All right, so really once and for all, I'm going to write sine of 30, cosine of 30, and tangent of 30. And I'm not going to go back to drawing this triangle every time that I need to. I'm going to start to memorize the ratios so I don't have to reinvent the wheel every time. All right, so your ratios are, the one opposite is the smallest. So it goes A, 2A, and root 3A, or A root 3. Just make sure you can see your A is not under the square root. Now we know sine is opposite over hypotenuse. And whatever A is, I'll always reduce, and that'll leave me with 1/2. All right, look at this. That's never going to change. But go to my calculator, and let me check my mode and see if I'm in degrees. I'm always in radians and calculus, which I'll teach you later. You're going to be in degrees for now. You wouldn't have your calculator for something like sine of 30. If you have to turn on your calculator in the future, find it in your backpack, turn it on, and check your mode and put in sine of 30. We're going to already be 3 problems down the road, so make sure you memorize what I tell you to. All right, sine of 30 is always going to be 1/2, no matter what. Cosine of 30, we're going to see a square root of 3 over 2. All right, so let me show you what that is. Square root of 3 over 2. Okay, you're going to know things like the sine of 90 degrees off the top of your head is 1, and things like that. All right, so let's go back to our notebook. Cosine of 30. So now we're on this one. Cosine of 30 is adjacent to this angle, adjacent over hypotenuse. Square root of 3A over hypotenuse 2A. So now no matter how big A is, all of these reduce down. These cancel, and it's always square root of 3 over 2. Cosine of 30, opposite over adjacent over hypotenuse, is always square root of 3 over 2. Now for tangent of 30. What is tangent? In the old days, you would have said opposite over adjacent. So A over square root of 3A gives me 1 over root 3. And there are teachers and books that leave that radical on the bottom, which is actually fine with me. But for now, we're going to rationalize it and make it square root of 3 over. This makes the square root of 3 times the square root of 3 is the square root of 9, or just 3. The square root by itself gets rid of it. Okay, so these are super important. Where I'm going to memorize for the rest of my life, sine of 30 is 1/2, cosine of 30 is square root of 3 over 2, and tangent of 30 is square root of 3 over 3. We're not going to keep drawing this. We're going to make our life a lot easier. Okay, so what I'm going to do is I'm going to start putting them in a chart that you are not going to write down yet, okay? So I'm going to go, in our chart, you're not writing this down. Trust me, by the time you write it down, you'll have it memorized, believe it or not. We're going to leave a little box here for radians when I teach them to you. Right now we're going to have degrees, 30, 45, and 60. And most people say it in this order, sine, cosine, tangent. And I'm going to put these in our box once and for all. And we're going to start memorizing. Like I say, by the time you write it down, you'll have it memorized. But I know the sine of 30 degrees, no matter how big the angle is, could be really, really big or really, really small. The ratios will always reduce to these numbers I got here. 1/2 the cosine of 30 degrees is square root of 3 over 2, and the tangent of 30 degrees is square root of 3 over 3. All right, that's that once and for all. Now let's go to 60. All right, so let's get a fresher triangle. Remember, we're always doing this from the closest x-axis. So we're talking about, like, we've gone over here and we've gotten a triangle, where now this is 60 degrees, and this one's 30, and this one's 90. All right, opposite this little angle, we don't know what it's going to be. We call it x or a, but whatever it is, the hypotenuse is 2a, and this is square root of 3a, which has been proven for a long time, and you can also prove it with the Pythagorean theorem. Make sure your a, some people write it a root 3 instead of square root of 3a, so you're sure the a is not under the square root. All right, let's find the sine of 60 once and for all. The sine of 60 is square root of 3a, square root of 3 times some number, opposite over hypotenuse. It cancels. Cosine of 60 is adjacent over hypotenuse. This cancels, and you get 1/2. And the tangent of 60 is going to be this number, square root of 3a, opposite over adjacent. Cancels, and you get root 3. So if I went to my calculator and punched in cosine of 60 or tangent of 60, I'll get square root of 3. It's that always and forever, just like 5 times 5 is 25. You don't have to start over and figure that out. So if I go tangent of 60, I'll get square root of 3, square root of 3. Okay. All right, so, and people memorize these. They just know them off the top of their head, just like 3 plus 5 is 8. You're going to have to know these. All right, so 60 is down here at the bottom. This is square root of 3 over 2, 1/2, and square root of 3. All right, I did the 30 and the 60 because they're really part of, they kind of go together in the 30, 60, 90 triangle. Now let's get a 45, 45 triangle where the sides are the same. Okay, so in a 45, 45 triangle, these are both A. They'd be the same. I didn't draw it very well, but it's an isosceles triangle. And this is our angle in question, 45 degrees. And this would also be 45, but that doesn't matter. We're looking at this one. And this is 2a. Sorry, square root of 2a, or a square root of 2. All right, so let's find this sine of 45 degrees. Sine of 45 degrees, and you always need to put the degree symbol, by the way, because eventually we could have 45 radians when you learn those, so you need to mark which one you're using, which I know you're not used to. All right, sine of 45 degrees, so that we can see it. I'm going to this angle, and I'm going opposite over hypotenuse, square root of 2a. These reduce, and I didn't leave much room here, so let me scoot this over because I'll have to fix that. All right, sine of 45 degrees, we said was opposite over hypotenuse. These cancel, and I get 1 over square root of 2, which some people actually leave. You'll see that. I had some college teachers that told me, that was weird, that actually just kept writing 1 over root 2. You'll see that sometimes. But we're going to rationalize ours. We won't always rationalize, but we're going to rationalize these. And most of the time in our class, we're going to call it square root of 2 over, that's just going to give me 2. Square root of 4 is 2. The square root times itself just gives us that number. The number's going to be positive while we're talking about real numbers. So sine of 45 is square root of 2 over 2. do it in black. Now, if you're looking at another website sometime or checking some answers and you see this and you've written down this, they're both the exact same number, 0.707. All right, now let's talk about the cosine of 45. The cosine of 45 should be easy to remember, and so should the tangent, because you're on an isosceles triangle. So the opposite and the adjacent are the same number. So if the sine of 45 is, well, we went ahead and called it square root of 2 over 2 when we rationalized it. Can't pick up the right pen, sorry. The cosine of 45 is also a over square root of 2a, adjacent over hypotenuse. And so we get that 1 over square root of 2 when our a's cancel. And then when you rationalize it, you get the same thing, square root of 2 over 2. But of course those should be the same in a 45-degree triangle. And tangent is 1. Why is tangent 1? Because it's an isosceles triangle, 45, 45, opposite over hypotenuse. I don't care what your sides are. If this is a number, this is going to be the same number. A over A is always going to be a 1-to-1 ratio. Now, I told you would know this by the time you wrote it down. One of my students a long time ago, named Robert Harris, when I taught co-ed, he told me the way he remembered it, and I've taught it that way ever since. So if we're in class, we'd say some of this together. And remember, before I teach you any of these other charts, always start low. Like sometimes you're going to forget, should I start with a 1 or a 3? And remember, I wrote this word low in red. You'll choose the low one, okay? So if you're choosing between two numbers in a chart and you've all of a sudden forgotten, should I go 1, 2, 3 or 3, 2, 1, start low. So we're going to start low with 1 and watch what happens. Okay, we're going to start with 1. Robert would go 1. I might need a better color that you can actually see. We'll use red. Okay, this is 1, 2, 3. This is 3, 2, 1. And the third column, if I was in class with you, I would hold up 3 fingers. The third column is 3, 1, 3, and then it always has 3 3s in it. The third column has 3 3s. The third column has 3 3s. So it goes 3, 1, 3. The extra 3 is right here. Now what I want you to notice about the second column. The second column is all divided by 2. I don't know how Robert notices, but it works. The second column is all divided by 2's. So if I was in class with you right now, I would hold up 2 fingers and notice that the second column, the first 2 columns are all divided by 2's. Sorry, my husband started working downstairs and it was distracting me. The first 2 columns are all divided by 2's. The third column has 3 3's. All right, right now you may not believe that you will have it memorized, but let me show you. All right, so I'll try to talk over what's happening, all the other people working in my apartment. All right, so sine, cosine, tangent. All right, so you'll draw this box. Most people still even put this on a test, even though eventually you have to have it memorized. But it's sort of a nice crutch. It's a helpful aid. You'll get to where if you do your homework, you'll memorize this and won't even need the box at all. You'll just know the tangent of 45 is 1. But right now, you'll want to look at this, and the key is that you look at it until you have it memorized, and then you don't even need that part of your memo page anymore. All right, so in this box, we're going to have radians, degrees, sine, cosine, tangent. All right, so watch this. I forgot one thing. Robert said he went 3, 4, 5, 6. So 30, 45, 60. Don't write anything down yet. You're just watching me. All right, remember to start low. If you're sitting on a test and you can't remember, or a quiz, and you go, oh, I don't remember if it's 6, 4, 5 or which way it goes. Start low, 3, 3, 4, 5, 6. And then you go 1, 2, 3, 3, 2, 1, 3, 1, 3. But the third column has 3 threes. Where's the third 3? It's always on the top. Then go to the first 2 columns, and they're all divided by 2. And then, they're all divided by 2. And then you square root everything except for 1. Square root of 1 is 1. So square root all the numerators. I'm not going to square root that one because the square root of 1 is 1. I'm going to square root these. Square root all the top numbers, all the 3s and 2s. And now you have it. For homework, and in just a minute when I work some problems with you, we're going to be able to use this. I'll show you. I'll go tangent of 45 is 1, kind of like using our multiplication tables until we memorize them. Again, don't fear the memorization. It will happen as you're doing your homework. And I'll give you quizzes on it, but we'll talk about that later, way later. Let's do it again. I had to get a pretty picture. I like this fall picture. Okay. So you can pause it after this and try to do it yourself. And we'll put it on your memo page in a minute. Okay, so sine, cosine, tangent. This is degrees and, radians and degrees is how I've been doing it. Stay consistent, radians and degrees. All right, so I'm going to go 3, 4, 5, 6. So that's 30, 45, 60. Think to yourself, you're going to go 1, 2, 3. 1. In fact, I call it the 1, 2, 3 chart. 1, 2, 3. 3, 2, 1. 3, 1, 3. The third column has 3 3s, so it's on the top. The first 2 columns are divided by 2. And then you go and square root all the 2s and 3s. You actually could square root the 1s, but square root of 1 is 1. So now hopefully you know it. All right, let's write it on your memo page. Okay, so this is the 1, 2, 3 chart, is the name I give it. Okay. All right, so it goes radians. We're going to save that open for now. We'll come back and fill it in later. Degrees, that's a little circle for degrees. Sine, cosine, tangent. All right, here we go. 3, 4, 5, 6. 1, 2, 3, 3, 2, 1, 3, 1, 3, 3. 1, 2, 3. 3, 2, 1. 3, 1, 3. And the third 3 is there. The first 2 columns are all divided by 2. And square root all the 2s and 3s. Now you'll be able to write this down for the rest of your life. Hopefully you won't need to. And you may want to write yours a little bit neater than mine. And so you can really see the square roots better. But there they are. We'll be using that in just a minute. And I'm going to keep going, so you may want to pause this while you write this down. Okay, that's all fine for what we call these reference angles. Okay, so if you land like here and you're getting a reference angle, but it's not helpful at all if you're right here or here. So if I land right on the axis, which ironically to me, I always thought it's kind of funny, it's called a quadrantal angle, which is not in a quadrant, so I don't know why it's called a quadrantal angle. It's landing between quadrants, but these are called our quadrantal angles. 90, 180, 270, and 360. Now SOHCAHTOA doesn't do us any good. I know that I'm giving you a lot today to process, but these are thetas. Tangent theta. Remember, while they may be opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, I was trying to switch you over to the fact that I showed you that sine was y opposite over r, which is the radius of this circle going around. Cosine is x over r, and tangent was y over x, okay? So we're going to really be able to use that really well up here at 90. Let's say that this is a 30-degree angle. If the radius of this was 10, then on a 30-degree angle, this would be half of that. This would be 5, and this would be 5 root 3. We don't have to ever draw this again, though, because we got our chart. We have it all laid out in our chart. Same thing's going to happen every time. No reason to keep doing it. We did that once and for all. This slide, I'm leaving that all behind now. That's all geometry. And this turns us into trigonometry. Okay, so we're going to use those facts. Now, this is really helpful when I get to 90. Up here, if I'm going around a circle, this point up here, if the radius is 10, would be 0, 10. This point over here would be negative 10, 0, if the radius is 10. This point down here would be 0, negative 10. And this point over here at 0 or 360, the radius would be 10, 0. And so I can use those facts to find sine, cosine, and tangent of something that doesn't even have, she's red so you can see it. This doesn't even have opposite, adjacent, and hypotenuse. Watch what happens as I get closer to 90. I'll lose my triangle for a minute, and it comes back out the other side as I'm going around my circle. I'm going to lose it again at 180, and so I really need trigonometry because at these angles, I don't even have a triangle. So I can't use the geometry that I learned. There's no opposite, adjacent, and hypotenuse. So for sine of 90, I'm going to use y. Let's write it up here. I'll write it right here. Sine of 90. We're going to find it once and for all. Sine of 90 is y over r. Remember, the radius is 10. So it's going to be 10 over 10. Sine of 90 is going to always be a 1-to-1 ratio. Cosine of 90. Cosine of 90 is going to be adjacent. Remember, the radius is 10. So cosine of 90 is going to be the x-coordinate over the r-coordinate. So our x-coordinate is 0 over 10. So it's going to give me 0. Tangent of 90, we've learned, is y over x from looking at these ratios. Y over x is true also at 90, but I can take my point instead of my SOHCAHTOA. I'm using a point. So I'm saying y over x. So I'm saying this y coordinate over my x coordinate. That gives me 10 over 0, which is undefined. And so that's how we're going to find all of these. So let's get a nice clean slide here to talk about what are called our quadrantal angles. Quadrantal angles. Okay. All right, so all we need are points, like whatever this radius is. Let's say this time the radius is 15. So this will be 15 units out. This will be 15 units up. This will be 15 units over. This will be 15 units down. And back. Sorry, that's a horrible circle. So my point is, a lot of times actually in trig, we use what's called a unit circle where the radius is 1. Because if we use a radius of 1, we don't have to reduce. That's why people use it. But I like to use different radii to show you that it works anyway. All right, so let's use this and find, let's use a chart and get all of our quadrantal angles in fact. And then I'll show you how to memorize this chart. Also, I learned this from a student too, actually. This is called the IOU chart. Radians, degrees, sine, cosine, tangent. Remember to always start low if your lowest quadrantal angle is 0. You're going to be really mad if you start at 90, because then all of your numbers will be off if you're using the chart method. 0, 90, 180, 270. You may wonder yourself why I don't have 360, but if I start at 0, remember they're coterminal, they're going to have all the same answers. So I don't need 360, I'm going to have the same exact result. All right, so, oh, sorry, I wrote those in the wrong thing. You should be writing anyway until I box it in. Okay, so start low, 0, we'll put the radians in later, 90, 180, and 270. Those are our quadrantal angles, okay? So over here at 0, we're using this, sine. Our newfound knowledge today is y over x. Cosine, sine is not y over x, sorry. Sine is y over r. Cosine is x over r. Tangent can be found always by putting the y over the x, which is opposite over adjacent if you have a triangle. All right, so sine is y over r. 0 over 15 is 0. So the sine of 0 is 0. All right, cosine is x over r. So I'm putting x over r. 15 over 15 is 1. Tangent is y over x. And you can't see my point anymore. It's right here. If I put y over x, I get 0 over 15, which is 0. Now 90, up here at 90, I'm going to find the sine. Sine is y over r. Radius is 15, that's 1. Cosine is x over r, that's 0. Tangent is y over x. 15 over 0 on the bottom is undefined, which you normally should write out the word undefined. We're going to write U to make our chart really cute. And that's where some people get the IOU chart, right there. All right, 180. Sine is y over r. We're going to get 0. Cosine is x over r. Negative 15 over 15 is negative 1. Tangent is y over x, 0 on the top. Down at 270, y over r is negative 15 over negative 15 is negative 1. Cosine is x over r, 0 on the top. Tangent is y over x. Here's my point. Kind of lost it in here. Y over x puts 0 on the bottom. You can always spend time going back and thinking about all of this, but we're just not going to reinvent it every time. We're doing it once and for all. That just gave me this 0 on the bottom, so this one's also undefined. All right, before we go further, writing a U in math nobody knows that you're talking undefined. On a test or a quiz, you actually have to write this out for me, undefined. Don't tell me something like tangent of 90 is equal to U. That doesn't make any sense. You would write undefined or abbreviated or something. But it's really good for our little chart because you can kind of see the word IOU in it. Let me call this our IOU chart, even though the I is actually a 1. All right, let's reproduce it. Now, I'll prove to you why it worked. So now let's write it down. All right, so you'll go degrees, radians, degrees, sine, cosine, tangent. And this is for the quadrantal angles, of which there's. Okay. So start low, 0, 90, 180, 270. So remember you're going 0, 90, 180, 270, and then it starts over again. The greatest thing about trig, the most important thing is it's cyclical. All right, now I'm not even looking at this one. All right, so what you're going to do is start low with a 0. All right, so you go 0, 1, 0, I, O, U, 0, 1, 0, I, O, U, and the last two ones are negative. Okay, let's try it again. So radians, degrees, sine, cosine, tangent. It's a good way to memorize it. That's all this is. All right, we'll fill in our radians later. Oh, see, I almost messed up. Start low, 0. These are zeros right here. 0, 90, 180, 270. All right, so I'm going to go, this is our IOU chart, 0, 1, 0, IOU, 0, 1, 0, IOU. The last two ones are negative. Let's get that on our memo page. Okay. So if I didn't have these pumpkins here, in fact, let's see if I can get rid of this pretty picture. It's kind of getting in my way. Okay, so here's my IOU chart on my memo page. We'll write it down, and then you don't write it yet. Let me write it again. You can be deciding how much space you want. All right, so this is sine, cosine, tangent. This is radians and degrees. All right, 0, 90, 180, 270. So it goes 0, 1, 0, IOU, 0, 1, 0, IOU. Obviously the I's are ones. The last two ones are negative. And that's your chart for your quadrantal angles. Now